Cool.
Cool. All right. Let's get started. Um, Welcome everybody to another Thursday night here at ISSessions. My name's Kurt. I'm current president, and it's a pleasure to host. We have a great meeting today, and I'll start us off with a quick rundown of what we have planned. Okay, first off, we have me doing the introduction, obviously. I'll also be, at the end of my introduction, I will quickly go over some free software for Sheridan students that's available to them. Some of it's obvious. I'm sure some of you have like Office 365 and Adobe stuff, but then there's some much more obtuse things that are free to us that is not really obvious, and I'm like the only person that really found it in my year. So I'll show you how to get to that. And then after that, we'll do the news roundup. We got Nishad and Adam helping us out today. So they'll give you a quick rundown of all the goings on in the InfoSec news. After that, at 7:30, we have a Repo Rundown presented by Nick. You might remember him from our previous guest panel. He's our program coordinator and going to show us his, I guess, favorite new repository. This one that he has taken an interest into. Following that, we'll have a short break, and then after our short break, we'll have our guest speaker, who's also one of our previous guests on our last sessions, Lee Kagan, and he's going to hit us up with some OSX exploitation knowledge. Now, I also do want to mention that our next sessions is scheduled for, like, we do them bi-weekly, right? So our next one was scheduled for, let me check here to make sure I got the dates correct. It was scheduled for October 22nd. However, that does fall on exam week, which I know is rough for us as executives and students to like attend if they have, especially if they have exams on Friday. So I'm going to post a quick poll in the, let me grab it one sec. I posted a quick poll. I'm going to emoji with that A and a B. Oops, that was the wrong person. So I would just ask you, just vote if you'd rather have it on the next ISSessions on reading week or exam week. Okay, it's already pretty solid reading week. Okay, yeah, so we'll probably have it on reading week. I guess that's clear. Cool. So I guess I'll show you really quickly some free software for our new students. See this. So my OBS capture. Oh, okay, there we go. So if you, I don't even know how to get to this. I just Googled Sheridan free software. Yeah, see. If you Google Sheridan free software, you'll get to here. You have Adobe Creative Cloud, Microsoft 365, VMware Horizon View clients. I don't even know what this is, but that's probably something interesting to look at. So yeah, I'm sure many people have found this already, these two. But then we also have On the Hub, which go down, go to On the Hub. Might not be able to log in because I might not be logged in. Oh, I am. Okay, so there's a free version of Windows 10 Education here. Don't put your credit card in any of this, I'd be honestly with you. Make sure you write down whatever CD keys this checkout service gives you. And then for our new students, I would strongly recommend that if you are using, you have to use VMs for any of your assignments or labs, I would recommend you get VM Fusion Pro for Windows or Mac, and VM Workstation Pro for Windows. Might be available for Linux too. I'm not 100% sure about that. Yeah, these are free for a year, and you can download a new CD key every year from this website to continue that. Also, what isn't obvious is it talks here about Microsoft's Imagine program. It like doesn't really tell you, like it tells you to go on the hub, which brings you here, which doesn't really tell you what that is, and I think it's some old legacy stuff they use. So if you actually go to portal.azure.com, and log in with your student account. So it'd be like last name or like first name, last name at SheridanCollege.ca, whatever your student account is. Pages Day, it's now Azure. Like yeah. So if you go to portal.azure.com and log into your student account, it'd be like your last name at Sheridan College. Like it'll take you to the Sheridan single sign-on. Once you get through that, it'll ask you to verify. Like there might be something up here telling you, asking you to verify your account. Once you've fully verified your account, if you click Education and then go to Software, Jamie Shin posting some links. So yeah, Azure for Education doesn't really necessarily get you to here, because I've tried to go through links to try to get to here, but it's nothing's really obvious. But yeah, you can get, these are like full. Okay, so yeah, it gets you there. But yeah, these are full versions. I think the only caveats are you can't sell them, you can't use them for commercial, obviously. But yeah, you can get PD keys for Windows Server 2019 here. There's probably like 10 versions of Windows 10 here if you want. This is great, all free for Sheridan students. I would strongly recommend you go through here and grab what you need, get your CD keys. Oh, does that after 5 years they validate? Okay, so that's interesting. I wasn't sure about that. I know if you try to grab more than 10 CD keys a day, it will lock you out. And I found that out and had to like go through some support page, and they're like, yeah, you can't. You're going too hard, man. Only 10 allowed a day. So yeah. So this is, remember, portal.azure.com. I'll leave a link in the Discord for you guys to go there as well. Cool. With that out of the way, Adam, do you have mouse control?
Yes, I do.
So up next, I'll just say up next we have Nishad and Adam with the news roundup.
Everyone, thanks for joining again. We have a great lineup of news. With we have a great lineup of news. So first up, a sad story. So ransomware crews have been targeting hospitals for quite some time now. So as you all know, hospitals play a critical role in society, and targeting them would inevitably lead to a death. And this is unfortunately what has happened in Germany. The hospital got ransomware, and as a result, they couldn't treat a patient. And while they were being transported to a second location, they died. Once the crews were notified of the event, they went ahead and gave up the decryption key and stopped their attack. In the article, they mentioned that the police are still investigating as to whether the cyber attack actually led to their death, like to determine whether they could be considered a homicide. So yeah, like hopefully governments now wake up. This has been, like I mentioned, has been speculated for quite some time that if ransomware crews keep targeting hospitals, this will unfortunately happen.
Okay, so next, it may not be a surprise that the web conferencing users who don't assign passwords to their meetings expose themselves to spoofing attacks. In July of 2019, the Prying-Eye vulnerability in Cisco and Zoom video conferencing platforms were discovered. This vulnerability can lead or allow threat actors to enumerate web conferencing APIs with a bot that cycles through and discovers valid meeting IDs, allowing them to listen to active meetings if no password is required. It is suggested that despite the ease of use and flexibilities that APIs provide, users should take a shared responsibility model and use the web conferencing vendor's security features to protect their meetings. Some web conferencing vendors have stated that they have taken steps to improve their server protection since the Prying-Eye vulnerability was discovered. Zoom and Cisco, for instance, say that they have implemented detection and prevention mechanisms in their data centers. They provide meeting hosts with protection controls, such as their waiting room feature, and ensuring that guests don't join without authentication.
Yeah, this is kind of interesting how we keep seeing attacks where the URL, like guessing the URL, gains you access to something that you shouldn't. Yeah, it keeps coming up as a problem. So
a recurring feature, definitely.
Yeah, absolutely. So sticking with the ransomware theme, so the official stance of the U.S. government is not to pay ransom. The U.S. Treasury Department sent out a warning stating that companies can face severe fines for violating the Office of Foreign Asset and Control. So this would apply to two groups. One is companies that have been hit with ransomware and are considering paying for ransom. This has happened quite often because like insurance companies or the companies that have been targeted, remediating and just restoring everything would just cost more money. And so paying the ransomware is a cheaper option. And we've seen other attacks as well, where, for example, ransomware crews would one ransomware crew would actually release the data if they didn't pay ransom as well. So it's kind of double whammy. And then the second group that would be impacted are companies that are involved in facilitating ransomware payment. So it can be a little complicated for like companies to handle those transactions through cryptocurrency. So services have spun up for this, and I imagine the government doesn't really want that industry, I guess. So this doesn't, based on the official stance, it doesn't ban paying ransom outright. However, it does if the ransomware crew is considered to be part of a state actor. So we've seen that, for example, ATPs and countries that have been hit with heavy sanctions, some of them have turned to cybercrime as a way to raise capital because of the heavy restrictions. And so it looks like the government kind of wants to prevent that flow of money. So it's kind of interesting. Like they don't, like sometimes it's hard to determine who's actually behind the attack. And so it kind of just muddies the water regarding whether you should pay or not, and whether there will be repercussions or not. It's kind of an interesting problem. This matter of like whether the attacker is a nation state or whether it's just a cybercrime gang, like the distinction keeps coming up. Like there was a story about how insurance companies wouldn't pay for cyber insurance if it was considered a state actor. So that seems to be kind of an interesting sticking point. And next up.
All right, so Google will be releasing their latest version of Chrome 86, in the next few days, fixing about 35 security bugs. There are two fixes or features that are notable here. For one, they will be fixing CVE 2020-15967, which exists in their payment component. This vulnerability is a use after free vulnerability, which is a memory corruption flaw, allowing for memory to be accessed after it's been freed. This can potentially lead to the execution of arbitrary code. It turns out that the use after free vulnerability is not a new vulnerability to Chrome, and it's also been used to compromise Chrome's printing, audio, and a password manager in the past. Also of note is their implementation of a feature to check if your password has been compromised. This is actually really interesting. The way this feature works is when a user tries to log into a website, Chrome will specially encrypt the username and password and compare it to a database of known pre-encrypted compromised username and passwords. If there's a match, the user will be informed and directed to the well-known change password URLs, essentially directing you to the right change password form so that you can sort of be hopefully assured that you're changing the password in a form that is legitimate.
That's pretty cool. Secuirty discovered a critical vulnerability in the Windows network authentication. So this affects all Windows Server versions from 2018 to 2019. This vulnerability allows a remote attacker the ability to bypass authentication completely. And because any user on the domain and using this vulnerability, an attacker having no privilege and remotely can become any user, including domain admin, which is like that means your whole domain is compromised like right away. The main requirement to exploit this vulnerability is to have network access to the the Windows server. So basically, like if you can get into the internal network where the domain controller resides, you can go ahead and exploit the vulnerability. Microsoft has issued a patch last month and highly recommends people to patch, mainly because exploit code for this vulnerability has been published, and also it's been, because of how critical it is, it's a 10 out of 10. It's being actively exploited in cyber attacks. So definitely patch your Windows domain controllers.
For sure. This one affects Mac users. So a researcher claims that the Apple devices with the T2 security chip are open to an exploit that could give threat actors root access. The T2 chip was intended to provide enhanced security by securing the Touch ID feature and provide the foundation for encrypted storage and secure boot capabilities. In order to exploit this device, the threat actor would actually need physical access to the device and insert a piece of hardware or other attached component into it to launch an attack. The researcher notes that it is possible to create a malicious USB-C cable that can be automatically exploit the device on boot. But if they are able to gain physical access, they can perform actions such as brute forcing Firewall 2 volume passwords, alter the Mac OS installation, and load arbitrary kernel extensions. This problem stems from two known issues: the Checkmate exploit, which leverages a boot ROM vulnerability, and the Blackbird vulnerability. These vulnerabilities can be exploited through Apple's debugging interface, which is open on the T2 chip, allowing for anyone to enter the device firmware update mode without authentication. Apple has not released a fix, and if someone suspects that their system has been tampered with, they can use Apple Configurator to install BridgeOS on the T2 chip.
Yeah, so this actually affects Intel Macs, as I understand. Not that there's any Android, but one of the notable things is Intel, within the Intel chipset, they offer the TPM, so the Trusted Platform Module, which stores secrets in a hardware level. This is similar to the T2 chip, but instead of using Intel's like Trusted Platform Module, Apple actually developed their own silicon called the T2 chip. And as I understand, it actually is quite similar to the Secure Enclave on iOS. So yeah, kind of interesting, that part. So then now, so ESET discovered a new state actor called XD Spy. They remained undetected for around 9 years. The group has been focused on reconnaissance and document theft, targeting both public and private entities in Eastern Europe and the Baltics. So that's the lighter blue on the map. This group used spear phishing campaigns to drop their initial payload. Their malware, so as you can see here in the diagram, this is kind of the attack flow that they've been using. They would use a spear phishing email. The user would click on a malicious attachment, which would download the XD down. So that's the dropper. So what this did was it would actually reach out and download the modules, like different modules, and then it would run those separately. So this was kind of like a modular approach to like, yeah, I found this kind of a modular approach, and also this prevented antivirus software from detecting Xdown as malicious. Instead, it would find the other malware. So yeah, so this group in particular, they really focused on remaining undetected in stealth. So the malware did not have any persistence mechanisms. So what that means is it did not save any files to disk. So a simple reboot of the machine would remove the infection. And also the files would delete themselves after a certain date. So they would kind of be able to cover up their trails.
So in case folks aren't busy with school, the NIST, or the National Institute of Standards and Technology, launched a $250,000 privacy technology competition this month. It's still going on, and if you're interested in participating, I've included the link in the slide. The competition has been organized to develop a technique aimed at making it more difficult to trace large data sets back to individual users. Specifically, they're looking at temporal and geographic data, which have personally identifiable information removed, leaving only class characteristics. The problem with class characteristics is that with a large data set, the data can be traced back to an individual. This is not a new concept, as we as humans do this all the time. An example of this would be if you had information on a person's age, gender, weight, and salary, there may be only a few people with this characteristic, allowing you to make a reasonable guess who that individual is. There have been attempts to create differential privacy. However, some of these techniques are not available to the public or don't hold up with large data sets. The competition has 3 prize paths, one gauging general success, one developing metrics to determine the success, and one in creating usable open source repositories of differential privacy technology.
It's a pretty cool, interesting competition. So like, I know, for example, I was listening about one of the techniques, this might not 100% apply, but like, for example, for training AI with large data sets, one of the ways to like protect the data is actually by hashing it. And then, so that way that you're not training the model on like the specific data itself. So for example, if you're training on like a specific name, you're not going to train it on the specific characters in the name, maybe just the hash. And that kind of adds ambiguity. So there's a bunch of different techniques in order to gain, in order to solve this problem. So we'll see if anything interesting comes out of it.
Definitely.
Okay. So a Chinese-speaking hacking group has been discovered by Kaspersky to be using a rare attack vector. So the group used UEFI malware to attack UEFI malware to act as a dropper for other malware to perform attacks. The UEFI firmware is the first part of the computer that turns on when you start up your computer and passes over control to the operating system during the boot sequence. In computing, the concept of trusting your computer is really important. However, you still need a single point of trust in order to build off of. And this is usually found in the earliest stages of the boot sequence and acts as a foundation to build on. So if the trust is compromised like early on in the boot sequence, then anything following it can't be trusted because it's been compromised. So this is why UEFI boot. So fortunately, UEFI bootkits, as they're known, are quite rare because they require physical access to modify the firmware. And they're usually achieved by 2 things. So one is supply chain attacks, which we have seen in the past, and also physical access. So if, for example, you have a device and someone can gain access to it and, for example, upload their firmware. So the bootkit was designed to install a malicious app and set it to auto-run on the operating system. So the scope seems to be quite small, as it was only found on 2 systems with the components of the malware framework in order for malware framework. It has been, but the malware, some of the malware has been found on other systems as well, but not the UEFI bootkit. So the targets seem to be diplomatic entities such as non-governmental organizations in Africa, Asia, and Europe. The malware framework seems to be stolen from the hacking team, which no longer exists as a company. So yeah. One second. There you go.
All right. So this one actually sort of was alluded to in the chat earlier, if anyone was there. Turns out that Twitter has a planned misinformation busting feature known as Birdwatch. It's intended to be a crowdsourcing way of tagging tweets as misleading, include notes explaining rationale, and flag for moderation. There's not much known about the feature right now, which was initially discovered by a reverse engineer who found hints of it within the website source code. Twitter confirmed the feature and quickly hid the code from public view, but it was rediscovered last week by another reverse engineer in their iOS application. This is all in an attempt to deal with mis and disinformation on their platform, because as we sort of know, mis and disinformation is becoming more and more impactful, not only from a social and political stance, but some individuals are actually acting on some of the misinformation that they're reading on these platforms.
Yeah, these platforms definitely have a huge amount of influence and sway in regarding to certain opinions. I just love the feature, how they called it Birdwatch. I just hope that when they actually release it, they keep the name.
I think they will, to be honest.
I hope so. Fingers crossed. Okay. Wait 1 second. Platform targeting. Yes, I'm sorry. So Facebook identified a sophisticated ad fraud campaign coming from a group that they called Silent Fade. The group would silently buy Facebook ads using compromised user accounts. So as you can see in the graph below, that was kind of this is kind of the process. So one is a Trojan would be installed on the victim's computer and then use it, and then that Trojan would access the default web browser of the user and check if there was a Facebook session ID there. So like whenever we use browser and we log in and we save our session, right? Then and so they kind of use that mechanism to be able to log in and impersonate the user. What the malware would do is it would look up the user's profile and check if and mainly check if there was any payment information. So this mainly targeted like business Facebook users that would have like their like payment information in the application. Once a user was identified to have payment information, it would actually disable notifications. And you would think, hey, wouldn't that notify the user? Well, good question. So they actually thought of that, and they would actually block Facebook from being able to message the user. So when Facebook tried sending notifications to the user, they were part of the blocked group. So the messages never got to the user. And then they actually use a bug within Facebook to prevent the user from removing Facebook from the bans list and regain control of their account. So kind of interesting. And so once this happened, the malware would gain persistence by replacing some of the program's files, so DDL files, for persistence. And also, since it had control of the browser, it made it on a legitimate user's computer. It was very difficult. It did a very good job of impersonating the user and not raising suspicion. So when the malware ended up buying Facebook ads for fake products, it didn't signal many flags because it wasn't from a random IP address. So Facebook managed to attribute the attack to a possible company that's been behind this attack, and they're currently in court with them trying to sort that out. So as Facebook and other large platforms grow in user base, and we end up doing most of our work on web browsers anyways, attacks like this that focus on a specific platform like Facebook, Amazon, etc., will continue to occur.
Okay. So what makes you feel more secure than filling out a CAPTCHA? It turns out that cyber attackers know how secure you feel and have recently been observed using a phishing page that featured CAPTCHA technology to give their victim a false sense of security, a form of social engineering. The use of multi-layer CAPTCHAs on a site has landed 3 advantages for the attackers. 1, the mechanism bypasses some web crawlers and security systems designed to find phishing sites. 2, the victim may be more confident in the site's legitimacy due to cognitive biases, as users often associate security and CAPTCHAs. It's also simple to implement CAPTCHAs on your website. It's free, open source. Google will even help you out doing it. there has been fake captchas discovered, which are essentially a graphical element on the landing page that appears to be a captcha but does nothing. Fake captchas are great because you don't need to deal with Google and their attempts to scrutinize your legitimacy. So how to spot a fraudulent captcha? For one, if you see a captcha on a blank page, it's probably not legitimate, as most legitimate sites use them as part of a login page. Also, if a site you frequent often never used the captcha in the past, and you click on a supposed link to the site and encountered one, it's likely suspicious. And of course, always check the URLs on any links in emails before you click on it. Although simple, it really does stress the importance of the human layer of security.
I wonder if the fake captchas like fail the first time and you have to do it a second time. Like, you have to enter in that text and you have no idea what you're typing in. I wonder if it'll pass it. That's a bit, yeah.
Or if you just enter something random and it lets you through.
Yeah, I wonder. That's like, that would be off-putting, It's like, I passed the captcha on the first try? All right. So for the next article, at least 5 bars and cafes in a city in France were taken into custody for not logging their Wi-Fi networks. The law that they apparently broke was made back in 2016, so quite a while ago, and it required all internet service providers to keep logs of all their users for at least a year. Now you might be thinking, this only applies to ISPs since it's internet service providers, but apparently not. Apparently, based on the interpretation, it's any person that provides internet, and these cafes, I guess, offered Wi-Fi to their customers. So I listed like the penalties down on the slide, so they seem quite severe. So it's kind of interesting why these 5 bars were targeted. Maybe I'm not sure what's going on, but yeah, kind of interesting since EU also kind of has been pushing for companies not to store information unnecessarily through regulations such as GDPR, where a company has to disclose what information they keep on users. Granted, it's mostly around PII, but still kind of an interesting take on that one. And this is sort of security related, but yeah, APIs have continued to rise in many products and platforms in general. So like, for example, popular sites like Twitter, GitHub, all have public APIs. So if you're wondering what an APIs are, they're basically like web applications, but without the pretty HTML. So you can see an example here where it's just straight JSON, and this is like a call to GitHub, for example. They're mainly used to pass data in a very formatted way and perform actions between programs. So they're not really meant for users. It's mostly between programs. Communication, because they just have the contents of the message and it tends not to change as often as web pages. And if you ever tried building like a web scraper, parsing HTML is a nightmare. The reason for the popularity of APIs is companies want to encourage integration with third parties. So building an API is a great way to foster that and make integration easier. Or internally also, like we have a lot of organizations might have multiple databases or random like data stores of information, and they'll also probably have a lot of different applications. So it makes it easier to have an API as a form of like a gateway to, and then they just control access and functions through the API, and then have that abstract all the different data on the back end. So it kind of makes sense from that point of view. So Cloudflare is a popular like CDN. So they do like firewall and they do anti-DDoSing and kind of edge stuff. And Cloudflare launched a free API security tool. They say to help reduce who has access to the API from the internet. So they have like ways of limiting so that random people can't just make API requests to your make random web API requests, even though your API is exposed to the internet, and also like reject bad requests before they even hit your API server, so they're not as vulnerable potentially. And so yeah, This is just kind of a little tidbit. Also, GitHub released a free code scanning tool. And I didn't include the name. So it's called CodeQL. It's available for public repositories and enterprise customers, but not GitHub organizations for some reason. We'll see. They function similar to like dependency graph, where you can enable the service on your repos and it's just kind of pre-configured, which is nice. You can see an example of where it's found actually on the image below. You go into security and then code scanning alerts, and then you can just select which one. They have support for other SaaS as well, but I haven't had a chance to play around with that. And the CodeQL product comes with default signatures for various popular languages. And you can also add your own as well. And they also have a CTF. One of the reasons why I wanted to bring this up was they also have a CTF around this. So if you want to practice like doing some detections or like learning what are some vulnerable lines of code that should be avoided, they have a CTF for it. So you can try your hand at that. Currently, it's for Java. So yeah, that pretty much covers the news. Thanks everyone for joining this week.
Yeah, awesome. Thank you, Adam and Nash. Anybody interested in doing the news, you can add it, or we can help add it to your CCR credits. If you're a Sheridan student, that is. So just get in touch with us, and we can I can get you working with Adam or Nash or me to do the news. Thanks, guys. Let's see. Next up, we have Repo Rundown. Nick, you here?
Yep. I'm
There you
just
go. Awesome.
clicking on share my screen. Oh no, how do I share it in like the actual presentation? Or are you just going to restream?
I am going to restream you.
Awesome. Okay, well, mine's up. It's shared. Can you see the thing?
Popping
Awesome.
it up.
Okay, cool, sweet, awesome. Hi, everybody. Hope you're all doing well on what is it, Thursday evening. So this is another random repo rundown. I picked one that I guess is a little bit popular right now for good reasons. So this is Atomic Red Team, kind of building off a previous MITRE attack framework one that we did like a little while ago, where you can just pull down the data on the MITRE attack. This one's actually allowing you to, in a sort of very atomic or unit testy kind of way, fire off individual tactics that are outlined in the MITRE attack framework. The project is brought to us by Red Canary, and their initial description is Atomic Red Team allows every security team to test their controls by executing simple atomic tests that exercise the same techniques used by adversaries, all mapped to MITRE's attack. As a side note, we all say like attack when we read the name of this framework. Really, like, since it's ATT and CK, you could almost make the argument to be like a tank, which would be kind of cool, but it's not. Anyway, moving along. Okay, so the repo itself, if you want to grab this thing and play along, like in your own time or whatever, you can just git clone it like that. So git clone, Red Canary Co / Atomic Red Team. You can. Now the thing about this is, as you'll see, all of the like atomic tests that you can run are the actual like meat of this project. But just to get started playing around with it, there are actually a couple of what they call execution frameworks bundled with the project. But they're not necessarily the way you're meant to interact with this exactly. But if you did want to, for example, install like the Python version of the execution framework, you can cd into this directory here. Pip install the requirements for Python, which is mostly like a YAML parsing library and like an encoding library. There's only 2 requirements, which is pretty simple. And the way you would execute one of the tests on the machine that you just installed this on would be to say Python runner.py, which is the sort of main Python application to do running, and then run as in the action you want to do, because you can run it in non-interactive mode, you can run it in interactive mode. This would be what you're seeing on screen is the non-interactive mode. T1033, and that's the like numbered test that you want to run. That one, for example, I think is like a user enumeration technique. So that's basically how you would do that. There's also a Ruby execution framework as well, which I will touch on in a little bit. But yeah, the running of it is pretty straightforward. The individual they call them atomics or tests. The individual tests may have separate requirements too if they have their own libraries that they have to run, but you can install that as part of running it. The overall organization of the repository kind of goes like this. All the stuff at the bottom that doesn't have like red lines coming from it, that's all kind of metadata setup stuff. Like the gem file is kind of Ruby's package management kind of platform. Libraries in Ruby are called gems. So all that is in there just to support adding in the like Ruby execution engine, stuff like that, and they get ignore file and the code of conduct file. The like meat and core of the application is in these folders. The first one's actually just miscellaneous files and stuff from the webcasts that they do about this project. So as far as actually running it, you don't need that content. The atomic red team folder is the specifications. So if you want to write some of the techniques or the test files to send in, that folder has the details that you need to know for like the YAML file format that they expect these things to be submitted in. The like meat of the project is the atomics directory. This is a directory that for each of the techniques contains 2 files, which we'll see in a minute or two, that really allow for the execution of these tests. The bin directory is actually not what we would normally expect for a bin directory in a project like this. They're not binaries that you're meant to execute. These are mostly like hooks within GitHub and stuff, so that when someone merges a pull request into this project, stuff out of the bin folder executes to like automatically generate documentation for the new test that's been added, which is super cool. The docs directory actually is the content to build the atomicredteam.io website, which is kind of an informational site. It has details on the APIs and how to use this thing. And then the last folder is the 2 execution frameworks, one for Ruby and one for Python, if you want to just from the command line kind of kick these things off. But again, the atomics are also built in a way that you can actually just copy and paste to the sort of malicious commands out of them and run them ad hoc. You can build them into scripts. You can do whatever you want with them. So like, since that's the core, I'm going to talk about the atomics first. We'll look at a couple of them just to see what the content looks like. And then I'll kind of show you one of the execution engines and how it runs. So, went too far, sorry. So for example, technique 1033, which is kind of system owner and user discovery. So the documentation supplied with this technique basically outlines the way you could generate this data using 3 different routes depending on the system or platform that you're running this test on. And it's cool because the actual documentation gives you the commands that you could literally copy and paste right out of the documentation. I can show you the website in a second. So for example, if you're on like the old cmd.exe prompt, the way like in Windows, the way you could run that. So this top left box here would be, it gives you just a series of commands that can be executed to do some kind of user discovery on the local machine. The window on the right shows the commands that would run to get similar data if you land on like a Linux box or a BSD machine or probably OS X. And on the bottom, it's similar if you're on Windows again. That would be the PowerShell line to do some user enumeration on that machine. So it's kind of really all these atomics and these tests are. They're just sequences of commands that you could run in a couple of different environments that simulate the kind of activity that is described in the tactics and techniques part of the MITRE ATT&CK framework. So what these allow you to do, or the whole reason you would want this, other than just to learn some of these commands yourself to understand what's going on, would be, say you want to test out, some of your alerting software, you want to test out some of your response, some of your detection capability. You would deploy some of these techniques on a particular system or on a series of them, and then just start running them. That would then trigger, sufficiently similar activity to what organized crime groups and APTs and stuff like that have been seen to do. So you can simulate that behavior to test yourselves, to test your security capabilities. They're also just a great learning resource too, for folks who just want to learn how you could actually do this yourself. Maybe you're a budding pen tester and you actually just want a list of commands that you can run to do stuff. These can also provide you with that kind of information. So here's what the actual code looks like though. So all of these test files, they're specified in YAML configuration files, YAML being YAML, or yet another markup language, I think is what it stands for. So you kind of define a test, and actually each test can have a number of subtests within it. So for example, for test 1027, obfuscated files or information, it actually contains 4 separate tests. So the first one basically runs bash commands to decode some base64 data into like a bash script and then execute it. So as you can see highlighted in this red box, there eventually you get down to a field in this configuration file that actually just contains straight up 4 lines of bash commands that would be executed on the machine that you run this test on. So in order, what they do is the first one basically starts a new shell subprocess and calls echo and prints that weird looking string there, which is just a base64 encoded plain text string, dumps that into /temps /encoded.dat. So that's going to be like your encoded data. Then we cat that file into base64-d, which decodes base64 data, and it stores the output of that in this art.sh. Then it assigns execute permissions to art.sh, and then it runs it. So really, that's kind of it. You could modify this test if you wanted to. All you'd have to do is replace that base64 encoded string with whatever activity you wanted to execute on the host platform. If you had an idea to make this more verbose, or you wanted to see if you can catch different types of behavior, by default, the activity basically just prints hello from Atomic Red Team. That's what that encoded string does. So you could kind of replace that with other text. But really, this is all that is in the giant collection of Atomic test files. So for example, within that same test file, though, like I said, there's 4 tests in this one. Here's a slightly more complex script, which is base64 encoded PowerShell. So right now, again, the default with this one is actually, it would prompt you for, kind of a, I guess like a string that you want to print. And it'll do the same thing. It will basically decode the string and execute it, but in PowerShell. So this is the version that would run in Windows. So before I move on to showing you how one of the runners works, I just want to show you what some of these things actually look like, the structure of this atomics folder. So if I go there, so here's like the giant collection of different techniques that are available. And so that first one we looked at, was it 1033, I think, the user enumeration. So each of these will have 2 files associated with it. If you just want to read through these, the one that's easy to read and the human readable one is the .md file, right? So we can open that one up. And it's nice, clear documentation that describes which technique out of the framework this comes from. It lists all of the various tests that this particular technique is going to demonstrate. And then for each test, it's got this nice kind of breakdown that shows you any parameters that are required, if it runs in bash, Windows command. And then literally the way it's structured, I could then just copy and paste this right out of here into a script that I maybe want to run on some machine that I'm testing our response capability on. Right. Again, I scroll down, there's the bash commands, scroll down further, there's the PowerShell command. So that's like the nice, clean documentation readable version, and that's auto-generated for you by this tool. All you would have to do is supply this, the YAML file, and their automated upload scripts convert all of this into that nice documentation. So here's the YAML file that has like, the description. It's got, then there's all the Windows cmd.exe commands. There's the bash commands, there's a PowerShell command, and again, there's just some metadata wrapped around that, which is a super cool thing. So again, if you get really bored and you want to find out, oh, well, what are actually some of the commands I would use to do these things? Here's a giant list of places you can play. Okay, so just to have a quick overview of how one of the runners works. This time we'll look at the Ruby one because I tend to only ever talk about Python. So the Ruby tool, like all the others, has all the other tools we cover here, has SIG ASCII art because that's just a requirement. If you're making command line tools, you must build SIG ASCII art. But really important stuff has a few imports, obviously a YAML parser because we need to parse all those YAML files. rbconfig is a way of accessing the current Ruby installation environment and getting things like module names and details about what host Ruby is currently running on, stuff like that. Time is just a time library for doing timestamp manipulation, things like that. Opt-parse is just for parsing command line args, and then net/http is just, it's interesting because the Python version actually pre-downloads all of the techniques, whereas the Ruby version only goes to the Atomic Red Team repository and fetches the individual technique you're about to execute. So that's why it's using a network library here. It just goes and fetches the one technique file and then executes and runs it. So after it does imports, basically the first thing that happens is it cleans up the command line arguments. If you're not familiar with Ruby, basically we're defining essentially like a couple of arrays without getting into detail. And then argv.eachDo as arg is basically a loop that iterates over all of the command line arguments that were passed to this program. It cleans them up by looking for things that started with -- input and does some splitting, some parsing, some separating basically of the argument name and its parameter or its value. And then eventually it builds those into sort of this set of variables here, like technique ID, test name, and repo. So the technique name that you pass it on the command line is what technique is going to be looked up by this program, fetched from the internet, and executed. So once we've sort of got all our command line arguments in place and all that stuff, then we go on to actually running the test, the technique, whatever it is. So basically, the top box here basically shows us calling execute and then passing it stuff like the technique ID and all those other details that might have been specified on the command line. Skipping over a bunch of stuff, but essentially execute grabs the test from the internet. I won't go too deep into that because we've looked at lots of code in the past where you just fetch something programmatically via HTTP, but it fetches that YAML file. And then it basically parses the command out of that YAML file. I showed you the commands a few minutes ago, what they look like. So it grabs whatever the command would be for the current platform that you're on. So again, if you're on Linux, it would grab the bash version of the command. If you're on Windows, it would grab either the PowerShell or the CMD version of the command. And then that's where it determines, hey, what platform are we on? And then it basically just fires it off to be executed by the host system. One of the things, and I don't necessarily love the Ruby language for a lot of reasons, but if you look at the bottom box here, there's a feature of Ruby that I absolutely love. So we've got this execute bash function where basically we're passing it a bash command because we've probably learned that, that we're on a bash platform. We've downloaded the code for bash or whatever. If you look at the second last line of this execute bash function, command results equals backtick bash-c pound curly braces command and then a closing backtick. That's literally how in Ruby you take a string and just pass it into a bash process. You basically execute this thing as a subprocess. Unlike Python, there's no calling like module subprocess.open passing in a whole slew of parameters. In Ruby, you can literally just say, a couple of backticks and then some, command evocation, and it will just go run that for you and take whatever would normally have been spit out on the command line and dump it into that command results variable, which is super cool. So really that's all the Ruby executor does. It goes, it fetches the technique from the internet, it looks up the command, it checks which platform you're on, and then it just dumps this thing to the command line and retrieves the results for you. And that's all the executor does. But you're not really meant to run it that way. I mean, I don't know if I would, because it might be a little bit frustrating to do that, because then you have to install Python or Ruby on the host you want to run it on and things like that. The cool thing about this is that at least the Python library, the way it's been structured and written, is that you can actually just import it into a Python script and execute it. Or because the way the documentation has been structured, or even the config file itself, since it's just written in YAML, you could write, a parser in PowerShell to download these things, open them up, and then execute the scripts inside them, freeing you of having to install any further dependencies like Python or Ruby. Just to kind of show you what that looks like. Here is how you could actually import the library right into your own Python program. So you import runner, and then basically you say techniques.execute, and then you basically pick the technique you want to run. And there's just a couple other parameters there, but that's it. Your own Python script would go and look up that technique and execute it. So you could chain a bunch of them together to simulate more sophisticated behavior. If you just wanted to take all the techniques and run them all at once, you could do that too. And you kind of have this like really loud, explodey behavior coming from one machine. I'm also aware that a number of people have taken, this repo and built more sophisticated tools around it, around like deploying the scripts in different places and using them, which is super cool. Ways you can use the Python library just in a straight up bash shell script, things like that. That's the Atomic Red Team website. So again, they detail sort of the API from Ruby and from Python and how it works, related projects that are using it. Yeah. And that's kind of this week's repo. It's not so much a focus on the runner as it is the atomic pieces, which personally I found a really interesting archive of individual commands that I might want to run as part of adversary emulation, or even just as like a new pen tester wanting to learn, oh, how would someone do this particular activity? If you want to make this into like a searchable database for yourself, you could download them, index them, search them. I'm sure someone's already done that, but yeah. That's it. That's the repo for this week. Hope that was interesting. And I will pass it back to whomever.
Awesome.
Probably Kurt.
Thank you, Nick. It is 8 o'clock, so we are going to go on break. If anybody has any questions for Nick during the break, post them in the stream questions chat. When we return from break, we will have our OSX exploitation presentation by Lee Kagan. So stick around. 5 minutes, guys. Cool. We can get started. I'm going to introduce you. Everybody, up next we have Lee Kagan. So you got a big resume here. Okay, Lee started in the IT and security world in 2010 in Toronto, Canada. When Lee isn't tiptoeing through enterprise Active Directory environments, he's running the DerbyCon Toronto community chapter, the Canadian Collegiate Cyber Exercise, C3X, and as an instructor teaching Canadian offensive and defensive professionals ways to up their game. Lee has spoken at multiple events and conferences such as B-Sides and Sector. In his spare time, Lee is an executive chef at a restaurant in his mind. Lee specializes in offensive R&D with a focus on Active Directory and defensive measures evasion techniques, malware development in C# and C++, C2 design, and management. Lee is practice lead for adversarial collaboration, purple team, at Layers prior to Layers, Lee was the senior offensive R&D specialist at Symantec. He was also a recent guest on our last guest panel. So everybody, Lee Kagan with OSX exploitation.
Awesome, thank you so much. Just for my own anxiety, everyone can still hear me, right?
Yep, you sound great.
Cool, awesome. All right, thanks everybody for having me back to talk again. This is a kind of a really really loosely thrown together kind of hacky walkthrough on attacking OSX, attacking Macs. It's starting to get a little bit more public attention, which is great because I think it's a little late. So I just wanted to kind of throw random things out and just walk you guys through the pieces that I think are really interesting. Comes to, you know, whether you have to simulate attacks against a Mac or you're working somewhere maybe where you have to do some defense against stuff for OSX. Okay, figure out how PowerPoint works. There we go. Cool. So really what we're going to go through, and I'm kind of winging it. The slides are somewhat cohesive, and then got a little VM set up that we'll walk a couple demo pieces through. But generally, I'm just going to explain one of the biggest things that people I've spoken to have had a difficulty with, especially if they're on offense and they're used to, sorry, the sirens are coming for me. If they're used to Windows, right? They go, wow, well, if an OSX gig comes up, all my tools go out the window. What do I use? Are things the same? Are they different? So I wanted to kind of do a quick walkthrough of really how not different they are from a, how you approach the scenarios. Kind of perspective. And then, of course, we know Macs don't have malware, right? Right? That's hopefully very old news. Nobody still believes that because it couldn't be less true. OSX, though, does have some really interesting security controls, especially in the most recent versions. They're actually quite impressive. And what's weird is out of the box, OSX can be kind of a, just on its own right from the store, semi-secure, like semi-hardened instance. And the second it gets joined to a company network or you're installing your own shitty apps and whatnot, it gets kind of weaker. But there's a lot of really cool stuff it has. And then just go over to a little attack and defend demo. So yeah, it's basically a smorgasbord, I have no clue if that's how it's spelled. That's how I hear it in my head. So sorry. And before I begin, everything I'm going to talk about here is on, shoulders of giants. These are all amazing, awesome people that are, always contributing amazing research freely and publicly. Cody Thomas is an awesome guy. He's the developer behind Mythic, which is what I'm going to use in the demo here. It's a kind of a command and control framework for OSX and others. Chris Ross and Cedric Owens, these guys make amazing offensive OSX research. Patrick Wardle, for anyone that's familiar with Objective-C, SEE, the website, they do amazing OSX security research and have these incredible, completely free kind of defensive tools you can put on your Mac if you're a Mac user that are badass. They're really great. And I have no clue if I'm pronouncing his name right. I think it's like Saba Fitzel, the Evil Bit, another person that puts out amazing research. So everything I'm showing you is really just kind of extracts from all the stuff that these people have put out and other researchers. So credit where it's due. All right, so who am I? It was pretty much already explained. I got nothing much to add to it. My name is Lee. I am the Director of Adversarial Collaboration at Laris, which is our purple teaming practice. And yeah, my main areas have really been Windows for a while, especially for developing malware and C2 management stuff. AD is something I'm very passionate about. And then really in the last couple of years, maybe 2 or 3 years, I noticed I would just be on situations where Macs were coming up more and more. And it was just one of those things like, all right, time to start learning a bit about this. I don't profess to be an expert in it. Windows is still really my domain, but I thought I've learned a few cool things and really wanted to share them with you. And yeah, music and food are kind of my big passions. I am, in my mind, much more better at them than in reality. So that's kind of my jam. All right, into stuff. So, you're used to Windows maybe, or maybe you've been doing a lot of stuff on Linux for a while, who knows? And all of a sudden one day you got to go do some security work on OS X. What does that look like? Oh my God, is it totally new? Do I have to relearn everything from the ground up? Not necessarily. A lot of things I'm going to go into and explain, I am literally just doing everything from the tip of the iceberg. I'm not going super deep into stuff, but these are sort of the little concepts that helped me transition to knowing what tooling might be available or how things work. So just as kind of an example, right? Like on Windows, process injection and code exec with these sort of initial access, stage 0 droppers and whatnot. Typically think maybe DLLs, right? On OS X, they have something called DyLib. Are they any different? Not really. They're kind of the same thing. Their purpose is the same thing. One's just called DLL, one's called DyLib. They're essentially identical in a lot of ways. You're going after credentials, right? So Windows, we think LSAS, Mimikatz, dumping LSAS, whatever it is. OS X, there's other things as well, but we got the key store. That's common in a lot of OS X offensive tooling, is to go after the key store. For those of you that have an OS X, you may have seen that app where it kind of records different certificates and passwords if you've saved them there. The Windows world, we got ActiveDirectory. Now, in OS X, you still have ActiveDirectory. You can join non-Windows things to an AD domain. But you have things like JamF, which is pretty popular. It's kind of a cool suite of different products that help you manage, administer, and secure OS X fleets, right? So it's the same kind of principle, just might not be AD, so your AD tools might not. Then on Windows, you got, the famous PowerShell, right? And one of the things that made PowerShell so famous was just the fact of what it could access, right? Like what a scripting language like PowerShell allowed you to get to, like .NET and went through 2 APIs. OS X has a lot of other cool stuff that's similar in ways. Now we know with OS X, there's the kind of Linux, Unix underbelly. So things that you could typically do on a Linux machine, bash scripting, Python, that kind of stuff, you can still do on OS X. But for something that's kind of Apple specific, they have something called OSScript, which is really cool. I think of it like the PowerShell for Apple. That's how my brain makes sense of it. It allows you to run all these other cool scripts like JavaScript and other stuff. And it for me, it feels very similar. And then let's think about, executables on Windows for the .exes, the .dlls, all that kind of stuff. On OS X, we have them too. We have just straight, their .apps or mock O's. We have the same thing, compiled binaries, your applications, right? So once you kind of start getting used to some language, it doesn't become a giant leap to figure out where to move to next for the understanding. So yeah, OS X malware. It's been around for quite a while. It just wasn't, as prevalent for many years because of the difference, obviously, in sort of market share of how many Windows machines are out there versus how many Macs. And it's still a Windows-dominated world by a long shot, but there's a lot more places that are not necessarily using Windows. They're using Chromebooks, or their Mac shops, or part of their setup is Mac. Who knows? But it's not just these sort of one-off, random, weird, kind of weak pieces of malware. There's some serious folks out there that have developed capabilities for OS X, and they can be highly effective. Just to mention a few. Lazarus Group, Tiny Shelf, and Fisher, OS X Evil Quest. Those, by the way, are just 4 relatively recent posts from one OS X security website. Right? There's many, many more. And if you're into malware analysis and you're like, I would like to take a look at some. Again, Objective-C, they have a repo right there. I think that's the current count, like 130 samples. You can just go grab them, like they share them with you. So there's some really cool stuff you can go check out in the OSX malware domain. And a really cool thing about malware analysis, even if it's entry-level analysis, kind of one-on-one stuff, it'll teach you a little bit about the system, right? Like, why are they running this command? Oh, it gets them this, you know what I mean? So it's a cool thing to go check out. All right, so let's talk a little bit about what OSX has in terms of its security controls, just on its own, like that Mac that you have in your hands, right? And like I said earlier, they actually have done a lot of great work for things that sometimes Windows people are screaming, why don't we have this yet? You know, OSX has done some good things. They've had their own problems as well, like anyone else. But they got some cool stuff. So I just kind of wanted to run through a short list because it's actually kind of long. So something that I think is one of the most cool things of late that I believe started with 10.15.4, I think. So Catalina is the endpoint security framework, and we're going to look at this a little bit later. This is essentially like the Windows event log, sort of sysmon style logs for Apple now. So process event creation, file creation, and then all the others, the deletion, the copying, the moving, the ability to track processes and their parent PIDs and their command line arguments. It's full-blown telemetry, and you can develop a little app to work with the ESF. That's pretty simple. Like you could write your own little EDR tool for your Mac just to tap into this thing. It's really amazing. So it gives you telemetry for what's happening on the system, which really is you know, in my opinion, that with the logs are the juicy stuff you want to get. File Vault 2, you know, which is the full disk encryption feature. On the hardware side, we have the famous Secure Enclave coprocessor for OSX, and I think you heard a little bit earlier about some issues with the chips there, but you know, they're making these efforts at least. The quarantine attribute was a cool thing. They started to see on more downloaded files, so potentially things that you had downloaded or maybe didn't know you were downloading would be marked with essentially kind of like a mark of the web style thing, but it was for the OSX quarantine, and you would have to remove that bit or you'd be prompted before it would even run. So we're going to touch on that kind of stuff a little bit later. That's a headache for attackers. So here's another, these are just still going. I think they're kind of cool to know that it has all this stuff. With the OSX security tool / features, not all of them are a nice little app, or not all of them are an easy command line tool. Some of them are just kind of obscure things that are there, that exist, that have configurations you probably wouldn't even go tinker with unless you were doing administration. So on the left in this list, directly actually from the Apple website, you have sort of their thing, and then what that would be an equivalent to in a third party. So they're sort of boasting, you know, hey, look, these are all the things that our operating system just comes with. So you have the plugin unapproved list for things like Safari extensions. File quarantine is actually a really cool thing. That was what I was talking about before. And also the file sandbox. You can run any file you want, any application inside a sandbox at any time. It has the Xprotect, which is sort of like their equivalent with virus definitions. MRT, their malware removal tool. Gatekeeper, this is one of the bigger pieces of application control that's becoming a tougher headache now for malware developers if you're going the compiled route, because they're requiring all this stuff now with a code signing cert from Apple, yada, yada, yada. They're making it hard, which is great. You have the EFI check, so again, to the T2 security chip. For kind of physical tampering, rootkit detection. And then they also have the application firewall itself. So firewall conditions specific to applications. Packet filter, no, you know, you would hope a computer in 2020 has some kind of firewall solution. And then these are sort of Apple's kind of proprietary, I don't know if I'm necessarily saying that correctly, but kind of their things where they're like, we do this. You can't really do much. Like you couldn't write an application and be a vendor for one of these things. So they're very Mac specific. And this is getting really what I'm talking about, why it's getting harder and harder to just sort of like, you know, compile a payload as a Mako or something like that and drop it to an OSX host and run it. They're starting to say, you know, no, we need this style of code signing from Apple certs with notarization. On the newest OSX versions, everything you do for the first time prompts the user, like, are you sure you want this to access file and folders? Do you want your terminal to be able to read files? Like you just get prompted for everything now. So it's getting a little bit harder, and they've made some great strides there. So one more time, I just want to give like a huge shout out for Objective-C, because the amazing research they give out is really phenomenal. So you can find them at objective-see.com. Patrick Wardle, I don't know if technically he's still quote unquote runs it, but he's definitely the individual that started all this stuff. So an amazing person to follow. And right here, you can see these are all apps for your Mac that are completely free. And if you kind of read over just what they do, you're like, oh shit, this is pretty sweet. You know, you have application firewalls there. Let me know if anyone's installed persistence. Show me tasks. Show me anything that's got an open socket. Show me kernel extensions, hijackable applications to DyLib injection. It's really cool. So if you've got a Mac, I suggest you go check out Objective-C's free security tools. So on that front, really all I'm trying to drive here is that, you know, there's plenty of great security features native to OS X that don't require something on top of it or an extra product. You know, it's a lot like Windows for that fact. We have tons and tons of great things that can prevent certain things from working or really make life harder for, you know, certain techniques to work. But as things, you know, get integrated into working environments, as users install and uninstall and change and blah, 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 things actually weirdly can get weaker sometimes just by the fact that now they're being used, you know, by a human, because we're responsible for all the horrible stuff. So, you know, even with the telemetry that you can now get off OS X with Endpoint Security Framework and all this stuff, at the end of the day, it's still useless unless it's being ingested, it's being analyzed, someone's doing something with it, someone's responding to events, so on and so forth. So, you know, it doesn't, just that it's there doesn't necessarily mean much. We got to be working with these solutions to make them beneficial. All right, so let's get into some of the attack stuff. So what I'm going to do, there's too many things I could try and squeeze in, so I just sort of cherry picked some things I thought would be cool. And, you know, so if you needed to get ready for an engagement against an OS X environment or whatever it is, Mythic is definitely what I highly recommend. Weirdly, the link's not there, but it's on another page. It was formerly called AppFell, so if anyone has heard or seen of AppFell, it is now Mythic. That's the same thing. Mythic is just the big upgrade. So that's going to be my sort of, I hate to call it this, but like my Cobalt Strike for attacking an OS X. And then what I love about Mythic specifically, and I'll touch on this here, is so when I'm thinking, all right, I have to, you know, go up against an OS X host, what are my payload format options? This is where things get interesting. So we know we could compile stuff. There's compiled binaries, and maybe if we do all the code signing, we could go that route. We know there's still scripting payloads that, you know, kick off reverse shells. Like we could use Python, we could use Bash and just do dumb pipes. We could use something called JXA, which is what I'm going to do. And JXA is a Java kind of automation bridge scripting language for OS X. It allows you to do a lot of very interesting stuff that on Windows would be like all of the stuff you do in PowerShell or C#, like, you know, finding shares and listing users and getting security configurations and checking persistence locations, blah, blah, blah. It's really, really helpful. And what's cool with Mythic is when we're creating the payload, we can decide at payload creation time how many embedded features and functions we want our payload to have. So do we want it to have the ability to upload or download files? Do we want it to have ability to do these kinds of post-exploitation tasks? Or maybe we want it to only have one thing it does, which is allows us to load other tools into memory. So we end up with this very tiny JXA payload that has no functionality other than it receives other JavaScript files in memory over the wire for added stuff. And that's what some of these are. Persistent JXA is a really cool library of different JavaScript JXA formatted persistent scripts that you can push through Mythic. Like they're sort of ready to work with Mythic. Swiftbelt is a really cool OS X version of a tool called Seatbelt. Seatbelt is a C# utility that does amazing like situational awareness on Windows and AD environments. It lets you know what you're working with, what's installed on the host, what settings are there. And then just some examples here of like other cool stuff. You can go after Slack tokens and files and history and all that kind of stuff. OS X also has macros, right? Some places use Microsoft Office for OS X. Now, one of the kind of things, though, where OS X did some good work was if you run a payload in Office on Apple, very likely it's going to run Sandbox, so you're going to have to deal with that. But it's still an option. You could absolutely fish with an Office document against a Mac user. On and on. The rest of these are just sort of like extra things that I would use to, whether I need to interact with a Mac that's joined to a domain, I might go with Orchard. If I know I'm just going to go after like Kerberos tickets and stuff like that, which by the way exist for Macs, I could use Bifrost. Point is, there's a lot of stuff out there to get you going. So I'm just going to kind of jump right into this little demo so you can see what some of these things look like. We'll see if I even get through them all, but really I'm going to show you what creating a JXA payload looks like, and we can look at it, infect the host, get a callback, and then run some kind of simple, maybe grab a screenshot, tell me what apps are installed, something like that. And then I'll show you what a very, very like hello world DyLib and Mako and all that kind of stuff looks like. I'll compile it and create it and then do these little DyLib injections, some persistence, and steal some creds with Kerberos and all that kind of stuff. And then kind of jump over to, some of the ways you could spot these things with some cool free tools. All right. Let me get rid of this thing. I apologize. The resolution is going to be really small, but when I put stuff up, I think for you to look at, I'll make it bigger as best as I can. So this is Mythic. I have it set up already. I'm just logging in, and what I'm going to do is create payload. So I'm going to say Mac OS. This is also what's badass about Mythic. You can do stuff only in the Chrome browser, which is a really cool thing. Linux, OS, Mac OS, Windows. It's got a lot of fun things. I'm going to pick an HTTP payload and change my domain. Now, here's where things get kind of cool. So I'm going to pick an app-fel payload. Oh, sorry guys, it's slow. Let me do that. All right. This is what I was talking about. I'm about to create the final payload. It's asking me what functionality do I want to bake in right now. So I might not necessarily want my payload that's running to be big or give away too much information. So I can choose any sort of random set of things I want the payload to have as a capability, right? Like what can it do? Now, for the sake of this, I'm just going to select them all. But I could do something where like I only make a payload that allows these two things. It allows me to import extra JavaScript and then call those functions in the JavaScript that I uploaded. And that would keep it very minimal. And if somebody grabbed the payload, they might not learn that much, hopefully, about what I'm up to. So it's just sort of a way to kind of minimize what your payload is built with. So we'll take that. Save you. All right. Come back to the VM. And sorry, bear with me one sec. I think it's this one. Okay. So we have this, I know it's very small. This says appfel2.js. It's a JavaScript file. I'll show you what it looks like, but this is actually in JXA. So it's not short, as you can see. Like I loaded it with functionality, but this contains everything that will assemble the agent, call out, stage, do its thing, do the key exchange, and run. Now it's highly commented, so when you're using this on an actual engagement, you kind of want to change stuff, obviously. But it's just a JavaScript file. It's not a compiled program. You can go in and look at how it works. and all that stuff. But that's not what we're here to do. Let's just kick it off. So you can run this. Now you can run these payloads in a few different ways. Just a simple command line one is with that tool OSScript that I mentioned before. So say OSScript, the language is JavaScript, and path to the file. Run that, come back to our C2, and hopefully we have a callback. Sweet. All right, so this is our beacon that just called back and checked in. So now I'm the attacker. I have some control over this machine. Let's get fancy. Why not? Good. Cool. So what can we do with this? Let's think. What do we want to do? We'll list some apps. So basically what I'm doing now is just some post-exploitation type stuff, like recon. I want to know more about the host I'm on. All right, so here we go. I can see different things that are installed. Maybe I have an exploit ready for one of them. Who knows? It's highlighting our process. So this is also interesting from a detection perspective. We're currently just running in an open hanging terminal. And that's just mainly because of the way I ran this, right? But our terminal essentially becomes our main PID for a lot of other stuff we're going to investigate later. Because right now, anything we're doing through this agent is going into memory unless it's one of those baked-in commands that actually call things that are kind of easy to pick up. Like if we do an ls, I think it's just going to launch /bin/sh or /ls, something like. It's going to call those bins themselves. So it's actually noisy in that way. But when we move into like uploading extra JavaScript stuff, it gets kind of stealthy, which is cool. So let's do one more. I don't know. Take a screenshot. This is actually going to take a few minutes. This is going to chunk the screenshot. Like it's only going to send a few little bits at a time. But that's one means of executing an agent on an OS X host. You can see it works pretty seamlessly, quite fluid. Now, this is what I was talking about. I don't know if you can see this, and I can't make this window any bigger. There's a little pop-up saying terminal would like to record this computer's screen. Now, this is what happens with a lot of new things that the terminal, for example, might want to access. So if the terminal was trying to, list a whole bunch of files and folders for the first time, it would pop up this consent form. This is one of the newer things that's making a lot of OS X attack tools and different tradecraft a little noisier if you're not testing them out ahead of time, because a lot of stuff that might run in the context of a terminal or other things will cause a lot of user prompts. So that's a little bit problematic, as a way to get burned on and off. So let me allow this. So think about this. A user would have to do this right now to allow my screenshot to finish. And they might be like, what the hell? Why does terminal want to record my screen? So just quit. Cool. So that actually just broke the functionality of the screenshot utility because I had to consent to this for the first time. That is kind of cool. All right, what else do we want to show? Let's see here. Process injection or DLL injection or library code execution. This is kind of another cool thing. Now I'm going to show a very, very basic example of this, but hopefully it's cool for you as well. All right, so we're going to take our simple app over here, and we are also going to take you. So really what I have is, I'll show you on the screen here. Oh, not you. We want a simple app. So this is something I'm going to compile. It's a very, very basic app, as you can see. So this will be compiled to a just standard kind of OS X equivalent binary app. Right now over here, this is a DyLib. This is as simple as it can be. Really, it's this kind of attribute being set that's changing this to a DyLib, for lack of better terms. So what we're going to do is compile this app here And I'm going to show you two ways that we can have our DLL here, which is our malicious thing. This thing here is our malware simulation, and how you can load it into an application in two different ways. Now, there's some caveats to how easy this is or how you would find an application vulnerable to this type of injection, but that's without going down the rabbit hole too much. So let's get compiling. Okay. So first we're going to compile the little simple app. Come over to my cheat sheet here. So let's run our simple app. So this is the thing that's saying, hello, I'm the app that is going to be injected into. So what we're going to do now is compile our DyLib, or some malware, so to speak. Cool. Now, just for a reminder, this is our simple app. This is before any injection. Okay, that's the output of it. Just says hello from the app being injected into. Now, one of the ways we can do this is sort of inline setting, essentially kind of like an environment variable. We can say this DLD_insert libraries, the path to a DyLib, and then the application. Now, the application is going to have to allow this insertion method, and that's part of vulnerable application scanning for DyLib hijacks and stuff like that. But in our simple example here, all we have to say from this point is where our DyLib is, which is here, and then our app. So now when we run this simple app, we can see the DyLib was injected into it, or called from it, I should say, and that code is executed as well. Now that's sort of like a kind of on-the-fly method of doing that. Another way you can do it is more permanently, where you can patch the application to contain an injected DLL, so that whenever that app runs, it's going to run along with your malware that's been embedded in it. So the next piece is, let me transfer over a file here. Here. There you are. All right. So this next program we have here, this is just like an application that's going to allow us to take in a binary, patch it with a DyLib, and then it's compiled a new binary with a file name called patched on it. So this is kind of like our injector. So we're going to say GCC. Oops. Yeah, we'll call it inserts DyLib. Cool. So now if we call inserts, so this is the new injector we just wrote. This is going to take the path to an application and inject a DLL into it. So we have our simple DyLib. This is our DLL, that's malware, if you will. And the app we want to shuttle that into now is simple app. So you can see here that there's this new attribute that's been added to simple app. Simple app is now, there's two versions, the original, and now there's a new one called simple app_patched. So if we run the old one, that one still works normally. If we run simple app patched, there's our DyLib message again. So the difference here was you can take like a simple OSX DLL that runs your evil thing. And if you find an application that allows either of these methods, either sort of a dynamic, please load this DLL next time you run style, or as you call it, or if you find one that is vulnerable to a DyLib injection through this attribute, you can essentially recreate the file, remove the old one, leave the patched one, and now that application's been backdoored. So there's that piece. I want to go back to app files for a second and show this JavaScript import stuff. So when we were making that payload and I selected all those different things, imagine I didn't and I just picked the JavaScript import function. So our payload that runs on the host, all it can do is load new JavaScript. If we're going to do that, I'm going to say JavaScript imports. It's going to ask me for a location. Let's pick, I'm going to load a JXA persistent script that allows me to backdoor Sublime text. Why? Because why not? You know, if you're a fan of a different text editor, maybe this makes you feel better to attack those people who use Sublime text like me. So that's been imported. What that means is any functions inside the script, I can now call directly through my appfill agent. So what I need to pull up is the one-liner for this. Sorry, 1 second. Let me actually grab it from my slide. All right, there we go. So it's got all these cool little persistence modules, and the one I'm using is this here. And you can see what it's going to do is modify the Sublime text main Python script file. And what that's going to do is add an extra little line to the end of it that's going to essentially launch one of our payloads if we have it dropped somewhere or we want to do a download cradle, something like that. So this is what I need. We'll come into our callback. Now we're going to say JS import call. And if I remember correctly, path was something like this. Users, we'll call it appfell.js, even though it's something different. This, move it there. Great. Okay. Sorry for all that setup. So we run that. Wait for that to call back. Sweet. And what we can do now is go look at what just happened. So this is the folder inside of the folder path for Sublime. Sublime has a sublime.py file, which is kind of like its main script here. And if you would load, that would be great. There we go. If I go all the way to the bottom, embedded in the very last part, this was just added by that persistence script. So now whenever Sublime gets called, it's going to run that extra little command at the bottom. And if you recognize that, that's what we ran our initial payload with. OSA script, L, JavaScript, path to our payload. So this is another cool way you could do persistence against applications. You can do them against doc items. So anything that's in the doc, you attach something that runs if you use it. There's a whole bunch of ways. A lot of them in the same sort of mentality as how you would do them on Windows. You know, registry kind of startup keys. We have plist and auto runs. Like all these things have the same equivalent on Apple. Okay, cool. I think I've showed just a couple decent attacks there. So we got an agent. You can run, by the way, in AppFell, or sorry, in Mythic with your agent, you can do all the command line stuff like ls. You can monitor the terminal for keystrokes. What it doesn't really help you with much is privilege escalation. Mainly because against OS X, it's kind of a different beast. Usually, some of the Linux style privesc things you might get lucky with. You can always go in and steal like Etsy Shadow and all that kind of stuff. But generally, it's not going to help you too much with privesc. All right. let's go take a look while this is running. At some OS query. OS query, if anyone's unfamiliar, is, I'll try to explain this in a good way. Oops, sorry, typing and talking at the same time. OS query is a really cool open source, free to a degree thing you can install. That it's like an agent. It'll run on OS X, it'll run on Linux, it'll run on Windows. It allows you to get access to a lot of telemetry, and it just allows you to browse them easily, run queries. It's very SQL syntax kind of like. And I just have it installed, some basic kind of out-of-the-box configurations. And what I'm doing here is dropping into an OS query interactive shell. And I'm going to start looking at like processes that are running or any of them calling out to the internet, you know, that kind of stuff, see what we can catch. So I'm just trying to read question. Can you leverage Methic implants with Cobalt Strikers, or better to use one or the other? That's a good question. Maybe I'll get to some questions if there's time at the end, if that helps. Just, I'm almost done here. All right, so OS query. Need to run it elevated. All right. So again, this allows you to run very SQL style queries, and you can develop some pretty complex hunts. You could also send this stuff off to Splunk and things like that for a SIEM, but I'm just going to use it directly in here. Let's start with something maybe like this. Okay, so what I'm saying, I'm actually going to change this. So what I'm saying is I would like to select, you know, we're going to mark something called S, and it's going to hold PIDs. P is going to hold names, the local address, remote address, net family, protocol, port, basically a giant Wireshark kind of filter, if you will. And we're going to create a nice little view of it. Now, in this particular query I had saved, this is to show maybe outliers, maybe things that are not web ports that are calling out to the internet, but our agent is using 80, so this would actually get missed. So I'm just going to replace these 2 ports we don't care about with things I actually don't.
Lee, can you do an extra zoom in?
Yeah, for sure. It's the wrong way. Why is it getting smaller? I think it might fly off the screen. Let's see. Is that a little better?
Yep.
Okay, cool. All right. So this is an example of the output. You can see it actually is kind of nice even from a terminal. So we're looking at PIDs, their names, their local address, what they might have a connection to, that kind of stuff. Now, this is actually not picking up what I have. And one of the main reasons is these are open sockets, whereas we're beaconing, we're kind of just calling out on an interval, closing down, calling out on an interval, closing down. Which is one of the downsides when you're looking for like open established sessions in something that's beaconing. But what I do like about this is you can take something like this and then say, okay, you know, let's say this PID was suspicious for whatever reason. We can do all these queries on the PID, like what's its parent? Where did it come from? What started it, right? And that might look something like, see if it likes this formatting. All right, so kind of very similar thing, but this is just looking for stuff that has open sockets and what their parent processes might be. And here we go. We just found our beacon. So we see the name to our PID, which is OSA script. So that's our running in our terminal, right? That's the actual binary that's running, and that's from user bin OSA script. Here's its command line that we're able to pull out. You know, the UID and GID that are set for it, how long it's been running, what it's calling out to, and on what port. So this is kind of a cool way to start looking at, you know, a hunt. We might want to say, okay, let's go grab this appfel script and see what it is. And that would reveal a lot. That would reveal more information about our C2. So it's kind of a cool way to look for stuff. And the lists, we could spend hours just going through different queries and long, crazy structures. But I think you get the idea that if you install OS Query, it does something that most EDRs and antivirus products struggle to do well. And that is in-depth monitoring of process creation and what started them and what they're running and all of that stuff, right? You kind of have it at your disposal. And with Apple's endpoint security framework, which is something I wanted to show you, you can literally write your own EDR like really quickly. This is the developer docs for endpoint security. It's not that helpful, I'll tell you that right now. But what they do have is this page on event types. And for anyone that's worked with, let's say, Windows event logs in any way, if you've ever seen them, or sysmon logs, I should say, which has a much smaller set of events, but they're very specific. You know, a process was called. Here's what it loaded. Here's its arguments. A file was deleted. A network connection was created. This is what those are for OS X. So you can kind of browse through these. So process event types gets the argument at a specific location for a process that started. It was created, what environment variables were set for it. This is telemetry. This is the stuff that if you know what set of these would maybe look malicious, these are the events that are going to fire when they do, right? So it's a really handy thing to start exploring if you're interested in OS X security, is just by having 10.15.5, I feel like it's on this page, 10.15 and up. That means your Mac already has this installed. These are just kind of C APIs. So you need to have something that's going to interact and get these events and then display them for you or send them off to a logging solution. But you can absolutely write like a little console app that does that for you. As a matter of fact, a really great example of this would be, make sure I can get this. Yeah. The SpecterOps folks did an amazing post. By the way, this fella here, Richie Cyrus, is one of the people I'm mentioning in the PowerPoint you saw earlier. So they actually wrote up a tool. You can read the whole blog post. It's really, really interesting. So here's those event types we just saw, right, from the developer site. And down here somewhere, they will have a link to this. This is their kind of wrapper for looking at these events. This is a tool that somebody made for you. You can just download it, compile it in Xcode, and it'll watch for all this type of stuff and more. It's really, really cool. And if you want to see as well what some of these look like, I actually have to switch over to a newer snapshot. If you bear with me. All right. So this is just a later snapshot where I've installed a whole bunch of that Objective-C stuff. That tool Appmon I just showed you actually is built a little bit on an Objective-C set of tools, Process Monitor and File Monitor. These are just command line things. So I'm going to show you what that looks like because this will be spitting out actual ESF telemetry. So the idea here, what I'm trying to demonstrate is if you were working on some sort of incident or whatever it is, and you had this telemetry, or maybe you wrote a little custom app or your EDR solution does this for you, you're in an incredibly powerful position to catch a lot of stuff. Oh, I am on the desktop. All right. I think it needs to be elevated. Get my one-liner. There we go. Let's do pretty. We can skip Apple. No. Now, I warn you, this is why dealing with logs and telemetry is difficult. I am just going to start something. I'm just going to start a new terminal. That's all. Okay. So here we go. Live process telemetry. And every one of these event fields is the event type, right? Like something was notify that this process ended, or notify this was created, notify something executed, something forked. I think it's going to be quite a lot of events just for bash running. And in each event, look at the amount of detail you get. You get the signing info, a whole bunch of stuff about that level, like the notarization, where this came from, command line arguments, its parent process, and any other parents to those, the path from where this launched from. I mean, this is the stuff that a lot of expensive products are telling you they provide you and they don't, and it's all sitting right here on your Mac. So I think it's a really cool thing to go explore. And let's see how long I've been going. I think that's kind of it, guys. I didn't really have any plan. I just wanted to start showing you this stuff and be like, yeah, OSX is hackable. So if unless anyone wants to chat questions or whatnot, I'm kind of out of slides, except for this. If anyone wants to grab this, everything I showed you, these are all the tools. I didn't actually show this one off or this one, but here's the link to Mythic. If you want to play around with the C2 install, it's really, really simple to set up. He just did a massive overhaul. It's like 2 commands. Here's that great post on writing your own little EDR with Atmon. And if you want to do those little DyLib insertion playing around, you can grab this. And this post down here by EvilBit is awesome. That's just where I pulled the information from. And that's it, guys. Sorry for that being a messy talk, but just wanted to share some cool stuff with you.
Awesome. Thank you, Lee. I'm going to unmute people's mics. Have questions. Okay.
Yeah, just a quick question with regards to, I think I asked it in chat earlier on about using Mythic with Cobalt Strike. Have you managed to do it, or is it worth using just one or the other?
Highly, I would totally say separate them.
Right, okay.
Yeah, I know. I've only seen, and I think the guy or whoever it was that put it on GitHub, there's some tool called like Cross C2, but it's like compiled already. He didn't release the source for it, and it's like it will take Cobalt Strike and make it OSX friendly, but it's kind of shady.
I mean, we've all learned from running random code on the internet's not the best idea, so.
No, I say just blind trust. Download it and pray.
I'm sure it'll be fine.
Any other questions? Okay. Well, thank you, Lee.
Thank you.
If anybody has or comes up with questions, you can reach Lee at invoke threat guy. Hold on. Let me make sure I got this right.
Yep, I think that's it. At invoke threat guy. Yeah.
At invoke threat guy on Twitter, or he's also in Discord. But yeah, Twitter's probably the best place to reach him.
Definitely.
For sure. We're also going to post this on YouTube. So if you didn't understand something and you need to rewatch it again, it'll be posted there probably tonight. To be uploaded.
Yeah, hit me up anytime for questions.
Other than that, yeah, thanks a lot. Thanks everybody for coming. Made perfect time. It's not, actually ended right at 9, which is like the first time we made it in time in 6 months. Oh, it's been a while. Great. Yeah, thank you everybody. We'll have, so based on the poll that I posted earlier, our next meeting will be on Reading Week, which is October 27th, 8th? 29th, my bad. And we'll have a great sessions planned for you then as well. John Simpson, who was one of our previous guests, will be there. Yeah, stay tuned for that. Stay tuned to Discord or our Twitter to get info on that. That's it. Yeah. Have a great night, everybody.
Thanks, everyone.
Thank you.